Welcome to the GOTO Podcast. In this episode, Markus Eisele and Natale Vinto, authors of the book Modernizing Enterprise Java, speak to Anna Maria Mihalceanu, developer advocate at Red Hat, about key ways to modernize your Java application. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, everybody. Welcome to GOTO Book Club. Today, I will be the host talking to my colleagues, Markus and Natale, who are awesome. And I will let them introduce themselves to you. So let's just take it alphabetically. Markus, go first.
Absolutely. Thanks, Anna, for having us. So I'm Markus Eisele, obviously based in Germany. Living in the wonderful land side of Munich in the northeast. I've been working for Red Hat since, I think, 2 years, and this is my second stint. My official title is actually Business Development Manager, but I like to think of myself as a developer strategist. So yeah, I guess that's all for now. We'll uncover more later. Natale, over to you.
Hey everyone, this is Natale from Italy. I'm a developer advocate here in Red Hat for OpenShift, which is the Kubernetes, the enterprise Kubernetes from Red Hat. I've been a software engineer, solution architect working in EMEA with OpenShift. Today I cover the developer advocacy for OpenShift, so all cloud native and Kubernetes with our customer, our community. So thank you for having me today.
So great to hear from you. I was so excited to host you today that I almost forgot what's going to be the subject of our conversation today. So Natale and Markus are the co-authors of Modernizing Enterprise Java, which is a concise cloud-native guide for developers. It's a recent released book to help us in modernizing Java applications. We've been hearing a lot about microservices in the past 10 years. But let me get straight to the point and, get to the point where we're talking about the painful stuff. In your opinion, what are the key points that we as developers should follow when we want to migrate from, let's say, legacy monolithic application to one that is following the cloud-native model? And any of you can start on this one.
Okay, let me start because that's kind of also the chapter order that we wrote the book in. So I'm responsible for all the great words and strategy and thinking, and Natale is actually doing the implementation. So as in real life, I'm kind of the architect behind this, and Natale is actually putting life and breath into all of this. I think it's not even the right question to ask, right? So the first question that should be answered, and that might actually not be a question for a developer. It might actually be a question for the business team behind what we're trying to create. We need to understand what the real requirements of an application are. So we've been implementing monolithic applications, host systems even, for the longest time ever. And we've been pretty successful. I built some of the largest enterprise Java-based systems in Germany. And to my knowledge, they never failed. So the specifications ultimately were the right ones. With our time changing significantly, our behaviors changing, our literal toys changing, smart devices, there's a significant shift in what the requirements from a business perspective are. One of my favorite examples is online banking. So every Monday morning, first of the month, half of the population is checking their online accounts, right? That is pushing a significant load on an application that has not been there before ever, because everybody was literally going to the bank or checking their post box for everything, right? So if the requirements the business personnel, the business teams have are ultimately suited to justify something like a distributed application in the broadest sense, then we can start talking about how to implement these kind of applications. So to me personally, everything starts at the non-functional requirements. How do we need to scale? How do we ultimately react to failure? So I'm team business requirements.
Okay, team implementation. What do you have to say?
Well, yeah, from an implementation perspective, we have instrument after the model. We have the theory, and then we have the instrument to start modernizing the application. So we have basically three approach that we outline and also in the book. For modernizing let's say monolithic app, you can do the re-hosting. You can do the re-platforming, and then you can do the refactoring. In this book, in the implementation part, we went into the refactoring. So we kind of split the monolith into several microservices, because this is the optimal choice, but it's not always the right choice. Maybe you want just to modernize some of part of it. Maybe you want just to move the monolith into a let's say container or Kubernetes. In the book, we took this approach, or starting splitting the monolith into microservice. And from an implementation perspective, we adopted modern Java framework such as Quarkus, such as the one you see in the t-shirt, in the cap of Markus, and I guess also the t-shirt from Anna. Yes, it's a modern Java framework to develop application in modern use cases, which is edge computing or serverless application. But also we used other frameworks that are popular in the Java ecosystem, like Spring Boot or reactive Java with Vertex. So we kind of had an overview of what the Java developer had today to adapt to the modern context of cloud native heterogeneous. So anything, an app today need to be really portable across multiple clouds if you want to scale and serve your customers in multiple environment.
Thank you, Natale. That was a great answer. And it reminded me why microservices are loved by so many teams, probably because when working with the monolith, it's very difficult to introduce change or to produce change and deploy those changes very quickly. And in our modern day, as Markus has mentioned earlier, we need some agility in terms of how we're doing things, and we require more flexibility with the applications that we're working with. However, my personal opinion as implementer, I still believe that monolithic applications have their places in the world. And as Markus has said, like everything starts with requirements, and especially take a look on the non-functional requirements. But do you think, in your opinion, that there are cases in which the approach of monolithic application is better? And if you have some examples, would help us.
There's a rule of thumb, right? So you mentioned that distributed applications have advantages when it comes to developing with different teams, having like agile approaches, zero coupling between the services. So it gives you a lot more freedom to ultimately develop. You can have the same kind of freedom in a monolithic application if it's well designed and well crafted. And usually if we're thinking about monolith, we think about these like insanely large applications that need like 15 minutes to start, the famous application server days, right? I think if we're not talking about these kind of monolith, but we're still talking about well architected ones, there's a bunch of non-functional requirements that ultimately would point towards a well architected monolith. One example is the traditional departmental application that does mostly CRUD operations, for example. So you could basically just use what enterprise Java gives you, ideally generate your complete persistence, have it like rolled out on a famous little desktop PC under somebody's desk, and 20 people keep using it, being super productive with it, right? If you want to run a worldwide global shopping cart, online shopping site, it's probably not the right choice. So it all comes down to what do I have to invest ultimately and which architecture to choose. And that's kind of like my rule of thumb. The easier your requirements are in terms of scalability, performance, users, simultaneous users, the more I personally tend to a monolithic architecture, because it's still easier to develop, in particular if you stick to enterprise Java. And the more you're breaking out of these like smaller functional requirements and non-functional requirements, the more you need to go fully distributed ultimately.
That's a very good point. And speaking about popular applications that all of us are using and loving, our browsers are like modular monoliths because we're having a core which we're adding extensions and plugins. So when we're looking at our IDEs, some of them have this type of architecture where they're actually a monolith. They're not necessarily microservices, and they still work awesome for all of us and do their job. So, Natale, any thoughts about implementing monoliths still in the real life? What would be your options in this case? Or would you always go to the distributed part, the distributed systems part?
Yeah, I mean, we have seen also in open source a project like the microservices are not the right choice all the time. It depends on the context, no? or the functional requirements, as Markus was saying. I can quote an example. Istio, a popular open source project for implementing service mesh in Kubernetes, started its control plane as microservice. But then they revert back and they went into a monolith. So it was too complicated managing that complexity with microservices that they went back into a monolith. So there are use cases where it's still valid, but in general, if your application needs to be scale up and distributed, the microservices approach is still valid. Even if it's a stateful application, there are today solutions that help your stateful app coexist into a more heterogeneous, more distributed world. And that's why in the book, we basically covered the whole book into a Kubernetes experience, because we thought that the easiness and the ecosystem bring by historically by application container like JBoss or Glassfish or Wildfly, today can be served and also by Kubernetes. In the book, we outline which of those functional requirements can be covered by Kubernetes, and Kubernetes also helps in either stateless but also stateful application deployment. And that's why Java developer, Java enterprise developer today can take benefit from frameworks like Microprofile, like Quarkus, and also the ecosystem from Kubernetes to get the same experience, the same easiness of developing application in business contexts.
Yeah, I was about to say as a matter of fact, what we're seeing across the board, and I personally believe this is going to be even more so in the coming years, is the stateful application itself on Kubernetes. Comes with a lot of challenges, in particular if you put something stateful on something stateless in general. But there's mix and match, right? So it might actually be a fact that your application doesn't have the same requirements all over. So maybe there's just a certain part that needs scaling. For example, the online account access for the online banking example I made earlier. So yeah, depending on what Kubernetes is a pretty great operational platform where you can put all these different workloads on top. The magic is to understand how all these bits and pieces wire together. In particular, while we as like seasoned developers also have a high interest in in regaining and keeping our existing knowledge. So, and this is totally selfish, right? So I've spent endless hours of implementing enterprise Java APIs, and now somebody's coming around the corner telling me to do everything else in like Rust or other languages. And I'm like, no, I know my APIs and I know that they've been suiting me pretty well. So, if you get an opportunity, as a developer to reuse your existing skills, for example, on the basis of microprofile, so like a subset plus extensions of full-blown Jakarta EE, that is definitely giving you an advantage in the field. So yes, go for Kubernetes. I think that's the message, but think about how to implement something on top. And Natale's example was spot on. So even the core functionality around application building on top of Kubernetes makes these choices day by day, right? So there is not just the one single answer. Speaking
about options and trying things, one important thing I love about your book when I read it and actually used the examples from it is that it has chapters with the theory explained correlated to the examples, and you can find the examples on GitHub. So, and you can reuse those examples for your own trials and see if they can help you and inspire you into creating your own microservices. I really love that that the examples come together and they do make an app. So probably a lot of the viewers and those that hear us are like wanting to get more into this approach, but don't have like a larger scale example. So kudos to that. And for the example shared there, I think it's good like to correlate theory and how it should be to the real life. So any other goals that you see achieved in the book to becoming more cloud native and you'd like to mention?
Well, Markus, I think we wanted just to give the subtitle is a concise cloud native guide. It's a starter point to your cloud native journey. This is what we would like to give to our readers that can have a theoretical overview, as you say, Anna, and then also practice. They can hands-on on Kubernetes locally. The example are on Minikube, which is a local Kubernetes environment for desktop. And also on cloud, we also have an environment called Developer Sandbox for OpenShift, which is free to use, where you can run all the exercise on this cloud Kubernetes environment. So yeah, I think Markus, correct me if I'm wrong, we wanted to give, we want to do the alley up for all the Java developer to score in this Kubernetes world. Yeah, absolutely correct. What I think was super important to me personally is to somewhat glue all the theory out there. There's so amazing books like Sam Newman, Chris Richardson. You can learn everything about how to build a decent microservice application out there. What I was missing mostly is trying to tie these things together on the one hand with existing Java specifications, with practical examples, that ideally was something that hundreds of people have already been trained on, and enrich all of this with a little bit of guidance around it. So I think we spent a significant amount of characters in this book on explaining migration path forward. So the assumption basically is you have some kind of Java setting that you want to conserve, treat as legacy, and like change it into heritage, take it forward. So find the right way of building the future for this project, right? So making the decisions around migration or rehosting or replatforming or a complete rewrite ultimately. So we're guiding people through all of this, but we're also ending in technical examples. And I think it's about time to at least say a little kudos to Alex and Madhu, two very valued coworkers who built this initial core of the example, and they've trained hundreds of people in Red Hat customers
with this example over the last couple of years. So it's not super artificial. It actually is a valued resource that we use with customers on a day-to-day basis. Natale put the cream on top and made it like look good and glittery ultimately. But at the core, this is something very practical. So you'll get the full download in a very concise way, and you don't have to like read millions of pages with all the theory. So it's kind of iterating. I want to believe that we did this because of COVID, because all our attention spans ultimately dropped to like almost zero. So you can even decide how you want to read this book. Do you want to read like 1, 3, and 5 from a chapter perspective? So you'll get all the theory and all the architecture thoughts around it. Or do you want to start with Natale's like hands-on examples? So you go like 2, 4, 6, and 7. Ultimately your choice. I have to admit it wasn't a deliberate choice. I think it's something that played out over time. It's amazing to write books with Natale. I don't know, somebody who's never written a book might not even distantly feel the pain, but there's a famous quote out there. So writing a book is as close as a male can get to having a baby, like giving birth. It is insanely painful to design a cohesive thought structure, come up with chapters. And Natale and I, we like naturally spit out these separation between the chapters. And I have to admit, I'm comparably proud of this approach. So I get my business development people to read my chapters, and it helps them. And on the other hand, we can still hand it out to like solid rock-proven SAs in the field, and they'll also learn a bit. So I think that's what I love the most about the book.
I remember that as a reader of technical books, I enjoy reading books that have concise chapters and examples like recipes in them. So like correlating the theory, not having too much written on a narrative, unless the concepts are really tough or new. And then have examples correlated with that. So, and that has been not, I would say, at least for myself, has not been something with COVID related, but has been something for many years, because we're all the time in the hurry to learn, to easily learn. And I think that there's no developer in this world that doesn't want to learn fast something and have a fast learning curve when approaching a new way of development, a new practice. So having a book like this structured is speeding up the learning curve. At least that's my perspective. And I have experience with other recipe books for other technologies where I read the book like this and I could get a grasp of the technology only for the areas where I was needing it. And that was like 10 years ago. So it's not, it's something that we want as developers, like learn fast. And that's where the book is helping us, and has helped me, for example, to learn fast all the concepts, acquire the concepts, see the practice, and put it to work. And speaking about migrations, can you speak to me about the challenges that you've seen when migrating, or that transition from the traditional application or vintage application, as I like to call it, to the modernized one?
Yeah, maybe I go first. A couple of anonymized customer cases. So what we see frequently across the board is applications that are not well architected. So technically speaking, traditional enterprise Java has like the 3-layer approach and is more or less artificially constructed out of modules. So it's not by design thought of as like a domain model underneath. It's mostly very entity driven, and from a modularity perspective, comparably technical. Translating these kind of technical monolith into something that is more domain driven is quite a challenge, to the point that customers might decide to rewrite things from scratch, which could be another challenge, in particular if you look at existing like real grown applications, meaning something that has been in service for more than 5 to 10 years. you will absolutely run into situations where you won't find the necessary specification anymore. Or people left who ultimately implemented an application, and it makes it impossible to even refactor something because you don't really know what you're going to break. There's usually only a very rudimentary test coverage on all of these applications. So it's like challenges from one to the other, but it all starts with what we typically refer to as the spaghetti kind of monolithic application. On the other hand, I've also seen very well architected and modularized applications, maybe even on the top of OSGI as a framework. And for these applications, it's really hard to justify the move to something that is stateless, because they already scale comparably well. And they still would need a complete technical overhaul underneath to rip out these like modularity frameworks. So challenges from a technical perspective, mostly due to design, older Java versions even. So basically preventing you from doing anything modular because you're tied to something that is really specific, proprietary. Just a couple of examples. Natale, anything else come to mind?
You outlined, and I think many valid use cases for that. And the challenges are the one also we mentioned in the book, right? We have to decide at that point if we want to start modernizing just some piece of the application. If we go into the refactoring, we need to estimate the effort for refactoring the whole application or the component. So I think the analysis phase requires some time, and it's the crucial one. It's the step where you decide the approach. We mentioned in the book the tree approach, right? And if you go into the refactoring, as we did, you have the help of frameworks, but this means also you need to rewrite the app. There are use cases where this is very valid, and there are use cases where it's not valid. So maybe you want just to leave one part of or one monolith up and running, and you just lift and shift in a container, and you start modernizing the other part that that are that are easier to do. So this is another approach. We can call it maybe hybrid, no? You split the complexity, and in your initial analysis, you estimate the effort for this migration. I think it's very important, this initial step where you do an analysis of what to migrate and what to do. And you have all the instrument as we go into the book to start adopting the right approach for you.
That's great. When Markus was mentioning the part with the legacy, with the apps and the architecture, I remembered that when it comes to modular monoliths, some people are having circular dependency between the modules. That shouldn't be happening. That should be a little bit independent. But I've seen that back in the day. However, OSGI is a great framework to start building on modular monoliths, but you can still achieve a nice way to have things loosely coupled, which I believe is a great point. So that's one way to look at things. And another way to look at things is like dependencies that you have in your app. So many of the legacies app, and Natale, you've seen this as well many times, have a lot of interdependencies and dependencies to some libraries that kind of force you to stick with one framework or one version of a framework or platform because of those dependencies. Probably some of them are not always maintained. That's an advantage to open source from my point of view, like always sticking to open source that are like maintained by a strong communities is a great advantage. And speaking about open source and frameworks, what do you think that container technology is bringing in terms of affecting speed of development for application development and deployment? So what are your thoughts on this one? So how containerization helps you in speeding up things for developing an app or in deploying it?
Yeah, I can take that. So containers is becoming also a standard for deploying application, right? So any new application is most of the time today a container because it's an open standard. And it's very important that this is open because any vendor can take the standard and do an hopefully open source implementation like we do in Red Hat, no? So the container is an open standard or an open API, which is the Open Container Initiative. You can take this standard and implement, and you have your Docker image, your container image. So the format is really important. If you think about in the past, it was hard to move an application from one side to another side. There was a zip file or another tarball or even an executable. The fat jar was not there. That we had a WAR file, no, the EAR file. So enterprise archive, web archive. Java brings some help in universality and portability, but that was not enough because of dependencies, as you said. So the application container like Tomcat, Wildfly was bringing those dependencies, but there were also the dependency of the operating system. Today with container, you basically have a kind of an operating system that brings you your dependencies, and then you have your runtime dependencies, you have your framework dependencies. So it's very valid approach to start using container for developing new application, but even porting old application. Because you can take benefit of this portability. Your app run in any cloud, public cloud, private cloud, your workstation, or any other place that has a container running. And I think this is very valid approach. And in the book also we cover the container creation of application from a Java perspective. With a framework like Gib or JCube, you can create a container from Java. You don't need any kind of Docker engine, Docker host. But also we cover the container engine, Docker. We mentioned Docker. We mentioned Podman. But also as a Java developer, you have the power to create this format, which is an open format, and distribute your application to any cloud.
Yeah, and adding to this, I think the challenge itself is developer velocity. So if we all agree on containers being the ideal way of moving application bits and pieces across various execution environments, on premises, cloud, whatever you want to, it's still comparably challenging to have a distributed system consisting of various containers, even locally emulated or tested or whatever. So there's good approaches. Test containers is one of them. There's also challenges, like imagine running Kafka locally on your machine, right? So Quarkus addresses these to a certain extent, thinking Red Panda. So there are a lot of developer productivity features hidden in various frameworks and platforms, to be honest. So if I think about something super specific that we're unfortunately not talking about in the book because we want it to be general purpose, obviously, but think about the OpenShift developer UI, right? So there's a lot of stuff in this UI that makes life for developers easy. Think about the service binding operator that you could use to just wire your application bits and pieces to Kafka queues and topics, for example. So I think as a general challenge in this field going forward, Kubernetes and containers, we will have to invest a lot more into developer productivity because, like, from a gut feeling from an old guy like me, I think we went down from 60-80% of coding in day-to-day to like 40% at max, because all the rest is going down the drain, configuring YAMLs and mingling around with kubectl commands, right? So in general, yes, I agree. It's a great packaging format. It has tons of advantages whenever we think about putting it into production, but there's also challenges that you need to like overcome as a development team to make this part of your new approach. And DevSecOps or whatever it's called these days is obviously also not the full answer to it, even if process is a part of it. So enough of rambling. Yes, I love it, but it takes a lot more. And I think we tried to help developers and architects navigate these various tips and bits and pieces more implicitly by using them and describing them and giving people like hints into the direction. But I think what we also said pretty clearly is we're taking an opinionated approach. So we're looking at the world in an ideal way. Like this is the Natale and Markus recommendation. If you want to be successful, go this way.
Yes, well, it's good to have a blueprint of success. And I think we've been looking to blueprints and patterns for a long time as developers, and not only. However, looking at how the world is right now, I think the first challenge is like how to build them when you have a legacy app, and then how to orchestrate them. Because making mini apps and putting them in a container is easy, but putting all the parts together and correlate them correctly and have them producing the expected outcome is one of the difficulties, or some of the difficulties that probably many developers and DevOps face nowadays. Speaking about, the fact that the book is agnostic from let's say, vendor technology. It tries to be agnostic as much as possible and keep it to open source, which I like it. What do you see that could be done in regards working with Java to improve the productivity of developers? So, because this is a book for Java developers.
Fair. Fair question, and actually a good one. I have to admit, it's hard to answer. I think what we've seen in the last couple of releases has been pretty solid in terms of container support, container detection, resource limitations, and we're actively not touching on that topic at all in the book, because I kind of assume that people are going at least with Java 11 these days. What I do think is that it also develops pretty quickly. Just a couple of weeks ago, for example, there's been a new open source project created called Creostud that basically launches like a sidecar container on Kubernetes, allows you to collect all your Java flight recorder recordings from the various JVMs running in your application. So we're still literally paving the path forward. Java, my personal perception right now as a language, is focusing a lot on improving use cases, APIs, and making sure people get the latest and greatest to implement whatever business functionality is needed. The runtime ecosystem, meaning the JDK or the general purpose VM, looking at Graal VM, for example, is kind of a similar development along the lines, right? So Graal VM obviously has insane advantages when it comes to running serverless workloads, instantly launching little functions, a small footprint, high packaging density on these Kubernetes hosts. I don't really know what I would want from Java at this point, because I think it's already pretty solid, well equipped to handle all kinds of container use cases. I think my direction would be more in the runtime area. So looking at how to connect the actual VMs, not naming a specific one at this case, and making sure they can be easily used as input for auto-scaling, even beyond the information we have as of today, which is basically memory consumption, CPU cycles, right? So maybe there's a way to even integrate profiling deeper in applications that could be relevant. And I think this is definitely something that comes into play more whenever we're thinking about really heavily distributed applications with many, many teensy little services going all the way to serverless. Somebody needs to have an overview about all of this. So it's mostly application profiling and monitoring for now. I think there's a lot of potential to follow through on that. Another opportunity I see is obviously runtime size. So thinking of the new hot topics, for example, Edge. So how can I deploy a piece of Java successfully in a containerized environment to like the most distributed infrastructures you can even distantly think of? There's a lot of improvements. The language itself, the runtime itself, I don't even have a wish list. So maybe I'm just happy as a Java champion. I don't know.
Well, speaking about wish lists, there are ways to make our wish list available thanks to the community, the Java community, which is quite big, and to have those wish lists taken into account. But yes, there are many more topics which Java is useful nowadays and I think is expanding. And I'm really grateful that the language itself in the past releases has been looking over to what other JVM languages had and improved on that for the developer experience when one using Java, for example, is a great opportunity and improvement. But since we're like touched also again the containers area, do you think that there is an impact on how containers are working on different infrastructure technologies or programming languages? Because, for example, this is a conversation I had like some years ago with a colleague of mine that was very fond of Node.js, that was telling me like, yeah, but I would not necessarily embrace Java when building microservices because I believe that doesn't give me the same agility as in terms of Node.js. Do you think that containers can help us in this case, like speed up Java when working with them on different infrastructure?
I don't think it's the format per se. I think it's the runtime, it's Java Virtual Machine Optimization and the framework. For instance, Quarkus has optimization to reduce the footprint of memory usage, speed up the boot time. It's using an application, a web server, which is Undertow, which is optimized for running the workload. So I think it's a matter of optimization and also supporting some programming model. Probably your friend like a more kind of the reactive way to express code, or this function code. So I think Java adapted itself in the years to many programming model. Historically, for the object-oriented programming model, now also went into, the reactive model, also the function model. So you have definitely the choice as a Java developer to pick the right approach, programming approach for you. And the frameworks also help you very much. The container, I think, still helps on the universality. The Node.js developer, the Java developer, the Rust developer, everyone use the container. There's no mess up with the operating system. We use the same format, can be a Docker file, can be the framework that create the container. Everyone use the container. Anyone is using indirectly also the 12-factor methodology. We mentioned the book, but this is a kind of a best approach on rules to write application. When you use a container, you're kind of also using this approach. You're making things generic, agnostic. You're using environment variable to inject configuration from outside. So your application is not hard coding anything. It's prepared for our best practices, and that's where the container helps any developer. It can be Java, Node.js. It's the format plus the implementation of such best practices when you start developing your application, which is universal. Yeah,
I couldn't agree more. Maybe one more thought. I mean, the ultimate advantage of Java is it has shown to scale. And not only as like physical executing applications, but also in terms of team sizes and supervising quality, for example. Like there's tons of plugins, PMD, whatever, to like make sure everybody's following the same rules. So we can, as an industry, as Java developers, we can deliver insane quality at scale, at large. And the knowledge inherited in all these people loving and using Java is basically something that needs to be conserved. And this is why I personally love Quarkus so much, because it basically takes this approach. So it conserves all the existing knowledge around APIs and behavior. It's like JPA on steroids, right? So you can literally use your existing knowledge and implement high-speed microservices. Is that because of containers? Probably a little, because it was kind of the initial factor, right? We're thinking about Kubernetes native applications that we want to deploy. But yes, the industry at large, on large, including the movement to containers, kind of forced us to become better and still work alongside existing APIs and conserve this knowledge, right? We can't just all start writing JavaScript for many reasons. Me in particularly not, but I'm just saying, so it might not be containers, but it might actually be started by them.
Yes, Java has been there for a couple of years, tens of years, and has proven to us that safe technology to be used is good for the future, and that's amazing. And yes, thanks to the fact that now is keeping up with all other programming models than object-oriented programming, the one that we started in school is a huge advantage. I think that we're kind of approaching to the end of our conversation, and would like to ask you a closing question about, in your book, do you address any of the misconceptions around being cloud native? Because cloud native in the beginning, when I heard the concept, it made me have this fear of missing out something. So do you have anything in the book about cloud native and misconceptions or this fear of missing out the cloud native that might help us also spiritually? Absolutely.
We're touching on what we think about cloud native in general. It's not a big secret. I mean, even if it's in the book's title, my preference would be to call it Kubernetes native. Because we're looking at a specific execution environment. The cloud could literally be a lot of things, and not necessarily be like based on this famous orchestration layer. Ultimately, I think we're not going through the theoretical parts of a 12-factor app or whatever people think cloud native is. We're more practical, to the point, defining what I think coworkers of us named the microservabilities. I'm messing that word up every time I speak it, but basically the bits and pieces around your application development for a Kubernetes environment. So to be Kubernetes native, I think I'm not totally over-promising, but we've been looking at pretty much everything that a Java developer needs today to be successful and find its path, right? Is that cloud native by the books, meaning 12-factor app? I'm not completely sure. We're definitely missing out on the team and DevOps thoughts around all of this. We basically recognize that this is a big piece of the puzzle, but we really wanted it to be technology and like everything one layer above, not 20. So I think that was, to me personally, one of the biggest challenges writing this book, finding the right flying height, if that translates, because just recapping what I learned over the past 20 years in this industry, I had the pleasure to learn like every single technology layer that came on top over the past 20 years, bit by bit, whenever it was released, and created ultimately. If somebody drops out of university today and wants to become a programmer and wants to be productive, like from day one, this is going to be a challenge, because there's so much to know, right? So making the right decision about things to talk about, was one of the challenges that we try to tackle by focusing really on that concise part and making sure it is relevant, even if it's a little bit of theory. So I guess that was a long answer for no, we don't. I was gonna say that, or maybe that's a good
a good starting point for another book.
Maybe.
Or a set of articles, just saying. But I like the duo that you have, like Markus and Natale have produced an amazing book, and I expect a lot of other good content coming from them. Well, yes, being a developer nowadays is indeed different from being a developer when I started being a developer, like a bit of more 10 years ago. 12 years ago, because what I felt at that time as a junior, that there's time for me to like get acquainted with everything. Well, today I feel that there are so many new technologies that is very difficult technologies and frameworks and so on. It is very difficult as a developer to keep up. Sometimes it's difficult and you can feel overwhelmed. And by the way, productivity from day one for a junior, I don't think that exists, but that's my personal opinion. Natale, anything that you would like to add to what Markus said? Because I don't know, he put the conclusion over there, but any of your personal thoughts would be awesome to hear.
Yeah, no, I agree that to keep that concise, as we wanted to make this book, we couldn't go into all what is cloud native. But what we did is put pointers, like we mentioned lots of other framework we couldn't use, like micrometers or micronauts for metrics in application, very important topic, or logging the application. So in some part, we rely on Kubernetes internals. In some other part, we mention other framework that would be useful for achieving that. We mentioned the service mesh, for instance, but we haven't implemented in the book. We implemented serverless, and we liked this approach because we thought it's a very valid approach coming in the future. We're having more IoT use cases, more machine learning, but we couldn't cover everything. So to keep it concise, we just go straight to some point, and for the others, we just have pointers or links, or we just mentioned the other technology. So to recap, I think this book is a great starting point when you want to start modernizing your Java application, but also when you want to have any Kubernetes native approach, you want to start understanding and start delivering your application with Kubernetes as a Java developer. I think this book is a really great fit for it. Yeah,
and if you ask me, they should make it mandatory for every university student to actually read it and buy it because,
But we should go to the university and do the evangelism.
Yeah, absolutely. It's absolutely perfect for them.
Yes, so thank you very much. That was amazing coming from the two of you. Well, the book is actually, there are ways to find the book available online, to read it online, the way that I have read it. Yes, I do agree that's a good starting point into this modern world, and especially for Java developers. It was done for you folks, for Java developers that want to still give a boost to the enterprise apps sector. I mean, that's an area that people didn't, I'm not say didn't, but it's an area that we should look more into and be more empathetic with those kind of apps. So kudos to both of you for writing an awesome book. And thank you for joining me today to the GOTO Book Club. Hope everybody has enjoyed the talk and can reach Markus and Natale on the social media because they're quite present on the social media to ask more questions and, of course, more details about what was written over there. So thank you very much for joining me. Again, kudos to our two awesome co-authors and my awesome colleagues as well. And hope you have a great day. Bye.
Thank you, everyone.
Thank you.
Bye-bye.
Bye.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.